Hello everyone, so today we are going to be solving simultaneous linear equations again, and we are going to be doing that by using the method of elimination. So these are the two equations we have. 5x minus 2y equals 14, so we'll call that equation 1. And we have 2x plus 2y equals 14, and we will call that equation 2. So let's begin. So when we do elimination, the idea is we need to be looking at these equations in a different way. So we need to be looking at it vertically. And what I mean by that is we are going to be looking at this pair of numbers together, this 5x and 2x, because they're both x's. We're going to be looking at these two together, this minus 2y and plus 2y together, because they are both coefficients of y. And then we're going to be looking at these together. So the first step in when you're doing elimination is, first of all, try and reorganize your equations so that the pairs line up one on top of the other, because that will make it a lot easier. When they line up one on top of each other, so like these are the ones for x, these are the ones for y, and these are the constants. So they don't have x or y, they don't have any alphabets, which is what we call variables. Anyway, so once they're aligned, now the key here is to look for the pair that have the same coefficient. The signs may not be the same, but look out for the ones where the coefficients are the same. So this is 5 and 2. They are the coefficients of x. They're not the same. So that will be quite a bit awkward to work with. But this is minus 2 and plus 2. So we have 2's, right? Two 2's. So, as I said, never mind the sign. This you can work with. So, now that we know this, what we're going to say is, okay, how can we make these pair get to 0? And that's what you want to think of. So if you say here plus 2y minus 2y, so this is plus 2 minus 2, which is essentially saying 2 minus 2. So what we're saying here is 2 minus 2. So let me just write this on the side so it's a bit clearer. So what we're saying here is plus 2y minus 2y, and hopefully you can see that that should be equal to 0. Okay, so now this is the key thing. Now that we can get to 0, so what we're going to say is, okay, so the plus 2y came from equation 2. And the minus 2y came from equation 1. So we're going to be saying equation 2 plus equation 1. Now this is going to sound really confusing because you're seeing a minus here. Think about it this way. Let me try and explain this better, and if it is not clear, let me know in the comments. So these are the coefficients, right? And we want to put a sign here that makes this equal to 0. Now let's do this by trying out something. If we put a minus here, now if you remember, minus minus becomes a plus. So this would be plus 2y plus 2y, which would then give you 4y. So this is not what we want. But if this was a plus, what we would get here is plus 2y, and we'd have plus and minus. Now plus and minus gives you a minus 2y equals 0. So here we know that it's 2y. We're adding these two equations. So we're saying so what we're going to do here is go back. Let me go back to green color. So what we're going to be doing here now is saying equation 2 plus equation 1. Okay, so let's do the adding. 2x plus 5x. So these are that group there. 2 plus 5 is 7x. So we're going to go 7x. Now we already have answered this here. 2y plus minus 2y, right, is 0. So we're going to just have plus 0. Doesn't really matter if it's a minus, but we'll stick with plus. Is equal to 14 plus 14 is 28. So we're saying 7x equals to 28. And we're going to then divide both sides of the equation by 7 because we're trying to free the x basically. So we do that by saying 7x divided by 7 equals to 28 divided by 7. So if we do the division, this becomes x, and 7 in 28 will give you 4. So x equals to 4. Right, so we've solved for x. But remember, this isn't the end because we still need to solve for y. And at this point, we can do some substitution. So now let's put x into equation 1. So we're going to replace x equal to 4 in equation 1. And you can do this for either equation. So we're going to move up here and continue over here. So 5 times x, and remember x is equal to 4. Oh, let's just rub that off because that doesn't look great, does it? Okay, so 5 times 4, right? And then we're going to say minus 2y equals 14. So 5 times 4 is 20. 20 minus 2y equals to 14. And now we're going to swap things over the equal sign. So we're going to start with a 20. Let's bring 14 over the equal sign. Remember here, because there's no sign here, this is automatically a plus. So if we bring it over the other side of the equal sign, remember when anything crosses the equal sign, the sign becomes the opposite. So this becomes 20 minus 14. And we are going to just put that there, 20 minus 14. And then equals to, now we're going to take the 2 minus 2y, don't forget the minus sign here, we're going to take the minus 2y over to the other side of the equation. And when we do that, it becomes plus 2y. So we'll leave out the plus and just write it as 2y. So 20 minus 14 is 6. 6 equals to 2y. So like before, we're going to divide both sides of the equation by 2. So 6 divided by 2 is 3. 3 equals to y, or we can have this as y equals to 3. So now we have solved for x over here, and we've also solved for y. But remember, we always have to check that it worked. So let's now play around with it in equation 2. So let's say equation 2 is 2x, right? So 2 times x, and x was 4, okay, plus 2 times y, and y is 3, equals to 14. So let's see, 2 times 4 is 8, plus 2 times 3 is 6, equals to 14. So now we know that obviously 8 plus 6 is 14, equals 14. So when we have this, we are confident that our solutions for x equal to 4 and y equals to 3 is correct. And we've done that using the process of elimination. So let me know what you think, and if you want me to solve something else, drop it in the comment section.